Hey everyone, so this is section 11.1, one-way ANOVA, question number 13, and the data already downloaded. So this is the table we got. We have 5 categories of food, all right, cat foods, and we want to figure out in 10 minutes how many ounces does the cat eat, and those are the numbers in the table. So the first question, we want to figure out whether these all the means are equal or not. All right, so the mean of the first kind of food, which is the kidney, shrimp, and so forth, right? So we have mu1 up to mu5, and not all of them are equals. The best choice should be B. All right, okay. The next question is asking about the F statistics, and that's you need to run the one-way ANOVA. So you just have to go to data, run the data analysis, one-way ANOVA. So select this one, it's gonna be all the way. This is the table. Then make sure you click on the labels, and alpha is by default 0.05, which is fine. And the output, let's put another output here, and it should be fine there. Okay. So this is my table, and what I need is the F stat. Copy it and paste it. Round to 2 decimals, so you're gonna be 9 there, and let's check it. Okay. Now they are asking about the F alpha. The F alpha is the F critical, right? So this is the F critical here. You don't need to use the table. All right, you could have done it, but it's faster with Excel, since by default to give you the F critical. All right, and round to 2 decimal places again. So good. All right, so here whether we can accept or reject. Obviously, if the F stat is bigger, larger than the F critical, all right, we would reject. So here we reject the null hypothesis. We have sufficient evidence to do that. Okay, so going back to the first hypothesis here, so we just rejected H0, which is this one. So then we agreed, or we have enough evidence that not all of them are equal. And for this reason, we're gonna use the Tukey test, all right? So we need to do the Tukey test, so hang in there. I'm gonna copy the table and get back. Okay, so I just copied the table here from a previous question. We're gonna fill it up together. This is the table from the book. As you can see here, this is my guidance, and this is my formula I'm gonna be used for the critical range. As well here, I copied the critical value standardized range Q at alpha 0.05 from the book. All right, well, from the exercise is given to you. I copied the values one because it's easier to manage. All right, okay, so we are ready to start. So first of all, let's define the groups, and this is my ANOVA table, the previous one, right? So what I'm going to do, I have the 5 groups here. So it's going to be 5 groups, 1 to 5. And then in here, I'm going to put equal sign and then select the first name, enter, and then drag it down. So this is going to give me the name of the 5 groups. So the first group is the kidney, second group is the shrimp, and so forth, right? Now, I need to figure out the corresponding sample mean. So the sample mean is the average. So for the kidney, for example, is 2.49 over here, right? So let me put equal sign, equals, and then I'm gonna select the first one and enter. And since they are in order here, I can go ahead and drag it as well. Okay, so I copy all of this value there. Sample size, I'm gonna do exactly the same thing. So equal sign, and they are all 6, but anyways, so if any change happen, you can do the same thing drag it down. So this is the NJs on the formula, NJ and NJ prime, right? Now the groups, well, the group, they are actually more, all right, because we have 5 groups here. We don't stop at 4. So the group 1 to 4 here, I'm going to extend it, all right. Basically, let's get this one down 1 cell, and this one is going to be extended. And Excel, it does understand somehow, right? So if you grab it from the corner and extend it, you're going to be 1 to 5 to group 5, right? So you can use that future. Here I have 2, 3. I want to go to 1 to 5, so I'm going to drag this one down, and I can drag this one more. So that's going to be 2, 4 and 2, 5. Then 3, 4, I need to go to 3, 5. All right. And the last one is obviously group. Let me change it better. So here is going to be group 4 to group 5. We don't have group 6, right? Okay. So we get all the possible combinations. All right. Now, for the absolute value, all right, absolute difference. So this one is going to be absolute ABS, open a parentheses, and you're going to do group 1 and group 2. So you're going to click on group 1 minus the group 2, which is group 2, this one. So supposedly you're going to do this for every one of them, all right? However, we can speed it up a little bit. So group 1 for the first 4 groups is not going to change. So we can lock group 1 with F4. Once you lock it, you can drag it up to group 1 only, right? And if you click on the last one, for example, you see that's group 1 and group 5. So we're good. I can do the same thing with the group 2 and 3. So this is equal sign ABS, open a parenthesis, and then group 2, which is this one, and can lock it, F4 minus group 3, this one, and enter. And then I'm gonna click on it and drag it all the way to group 2. And you can double check again by double clicking. You see that's what you want to see, group 2 and group 5. Okay, 3 and 4. So you're going to be equal sign ABS, absolute value, and group 3 will be this one. You want to lock it again, minus group 4, this one, and enter. And you can drag it only 1 cell down. The last one is going to be equal sign absolute value of the last 2 groups, which is 4 minus 5, and enter. So I get all the groups. All right. Now I need the critical range, so I have to go back to this my small table. So level of significance 0.05, number degree, numerator degree of freedom. So that's how many columns you have, and that's going to be 5. And denominator degree of freedom, that's going to be this one within groups. So you're going to put equal sign, and you put the number over here, or type 25 right away. The MSW, which is mean square within groups, and that's going to be equal sign, and that's going to be within groups, this one, right? There you go. So the Q statistic here is going to be depending from the degree of freedom, 5 and 25. So I can put equal sign, go to my formula, or table, sorry. So the 5 numerator is this column over here. I have to follow it all the way to 24, I think, or 25. So I have 25. The closest one is 24. So 5 and 24, this is going to be this value, 417, and enter. Okay, so I have this table filled up already. It's time to use the critical range formula. So I'm going to apply this formula here right now. So you're going to be equal sign. I'm going to select the Q alpha, which is 417, multiply, all right, shift and 8. square root SQRT, open a parenthesis. So MSW, that's going to be this value, divide by 2, multiply, open a parenthesis, 1, divide by NJ, which is 6 in this case, plus 1 over 6 again, and close the parenthesis twice, enter. So this is the value, all right? So this is what we call the critical range. Okay, so what we're gonna do, we're gonna place it over here, right? So I can copy it, copy and paste, and put the value, and we paste it. There you go, that's the value. All right, and then you can drag it down all the way. So this is the same value, right? Okay, the result. So the result here is going to be an if statement. So equal sign if. So if I have the absolute of difference, right, greater than the critical range, I'm gonna come up with a statement that the means are different. So let me put it in. So if, put the logical statement, that value greater than this value, all right, the critical range, comma, and between quotation you can put the statement. So the statement will be means are different. Then you're gonna use comma again. So in the opposite scenario right now, you're gonna come up with the opposite statement, which is the means are not different. Close the parentheses and all set. So the first statement here is going to be the mean are not different. You drag it down and that's what you got, right? So the only means are not different, they are this 3. We can highlight them, put a yellow on them. Okay, so group 1 and 2 are not different, 1 and 3 are not different, and 2 and 3 are not different. So I hope this is clear. Now let's go and proceed with the answers, all right? So here is using the same description, group 1, group 2, so accordingly, which is good. So the first two groups are different or not, all right? And they are saying not different, so we're gonna say no, all right? Good. Now it's saying 1 and 3. So 1 and 3 is this one, the second one, 1 and 3. So if they are following the same steps as well, right? Okay, so they are not different. We're gonna say no again, check, good. Now 1 and 4, yes, they are different, good. 1 and 5, 1 and 5 is right here, you can follow it. They are different, yes. So the last no will be 2 and 3, which is this one. This will be no, check it, we're good. Everything else should be yes, so we're gonna keep clicking on yes. Okay, all set. So we finished the Tukey Karmer procedure, right? So that's all. Okay, so now we need to double check that the variances are not different neither, because if the variances are different, if we have enough proof, the calculation that we did is doubtful, all right, and is not precise. So for this case, as mentioned in the previous one, we have the variance 1 squared, sigma 1 squared, all right? So equals sigma 2 squared equals sigma 5 squared, and then not all of them are equals, right? So we're gonna say this one, good. Now we wanna find the statistical value, so this is gonna be another work. So let's try to do it together, right? Okay, so what I need from here, I need just the table. I'm gonna I'm gonna copy this table again, and we're gonna start right here. All right, so once I get this table, I want to calculate the medians. All right, so this is a median, equal sign, and median, right? And then select all these values here, enter. That's the first median. I can drag it and get the remaining medians, right? Copy the table one more time, paste it, and clear all the data inside. Okay, so for the first cell, I'm gonna type in equal sign. So this is gonna be the absolute value from the value and the median. So absolute value, open a parenthesis, and it's gonna be this value minus the median. Close the parenthesis and enter. So this is the first one. And what happens if I drag it on the side horizontally? I will get the remaining ones, right? So you can double click, you see here, I'm making a difference. That will save you some time. Now what you're gonna do, you're gonna go back to the first cell, double click, you're gonna click on the median cell, which is the red one for me, and then I'm gonna lock it, F4, and enter. So once I lock it down, I'm gonna drag it, and that's gonna give me the remaining values. So what you want to see here, if I double click on this, I want to see the cell before the last one and the median. And that's what I have here, right? Good. So I'm going to do the same thing with all of them. So hang in there. Okay, once I locked the median cells, I'm going to select them all at once and drag it down. Okay, double check again, go random cell, double click, and you can see is the difference between the median and the cell before the last one. All right, so that's what you want to see, right? Done. Now this is my new table, and what I want to do, I want to run ANOVA, one-way ANOVA on this. Okay, let's try to do this. So you're gonna go to data analysis, single factor, select the cells here, all the table. Okay, labels on, alpha 005, and the output range, let's put it right here. Okay, done. Okay, so this is your new F distribution table, and we need the F value from there. Copy it and paste it. You want to run to 2 decimal places, so this is going to be 5.3, and we don't want to reject this. We want to have 8.0. 8.0 is good for us in this case. We want to double check that the variances are equals. All right, so that's what we want to do first. Okay, so in fact the F statistic is smaller than the F critical. The F critical will be this value. All right, so I just want to make sure that to review how I'm making my conclusion again. So what I'm giving here, I'm giving the F, so the F critical I get 2.76, and the F stat that I found, all right, is 0.53. So 0.53 probably somewhere here, right? So this is the F stat, which is 0.53. All right, so if this is 2, obviously this is 0.53 is before, right? And you see is located in no rejection zone, and this is 8.0. Do not reject 8.0. All right, and 8.0, in fact, this one is what I have here, that all the sigmas are sigma 1 squared and sigma 2 squared all the way to sigma 5 squared are equals 0.53, and this is 2.76. all right, so obviously this inequality is wrong. It's the other way. If it is the other way, I will take the other statement, do not reject, and this is what I'm following, right? Okay. So again, if f stat is less than f alpha, do not reject. All right, so I hope this is clear. Let's go back to the question. So this one did not reject, and if I did not reject, that means I don't have evidence, insufficient evidence. Great. Okay, so for the last question, I needed to go to the Tukey multiple comparison, right? So our conclusion came up that not all the means are the same, and that's the first question, right? Okay, so the means are different. If they are different, it means they are bigger and smaller. All right, that's one of the possibilities, right? And looking at the values, I can tell here that this is the biggest value. All right, then it could come this one or this one. So these three, they are highest values. All right, and on the other hand, we have this value is the smallest one, so most likely the beef is the smaller. As well 1.9, which is the salmon. All right, so you can tell here that if you are looking for the highest value, all right, for expansion, obviously we want the highest value, right? So if you are looking for the highest value for expansions, you wanna get the bigger value, right? And one of these choices will be okay. Now the bad choice will be for expansion will be taking a salmon or beef. The good choice would be kidney, shrimp, or chicken liver. All right, so for this, obviously we are not choosing C. They are telling you here the salmon base cut food is the best choice for expansion. Actually, the salmon is from the lowest one, right? So definitely not. And this A is wrong. For the second one, it's saying the chicken liver based cut food is the best choice for expansion. And yeah, it's kind of from the first one, right? So 2.40 is almost from the first one, right? So this will be most likely my choice. All right. The salmon based cut food is a possibility for expansion. It means the amount of food eaten. Okay, so they keep talking about the salmon here. Well, the salmon is better than beef, yes. Salmon is better than beef, but is less than the other ones. So there is no contradiction. We'll go with that. All right. And let's check it. Good. Done.